So simply, we were talking like, again, we were saying, for the ones who came late, we were saying that in your home or at school you have access points everywhere, yes? And these access points, the internet speed of these access points heavily dependent on the number of users that they connect to. Okay, agree with me? For example, if you are alone at home and you connect to the access point, you will get, and the speed of the internet, let's say the one you are getting from the internet service provider is 100 mega, you will get the 100 mega. But if you and your friend and your other friend or 10 people of you as a group enter to the room and all of you connect to the base station together, then the internet speed will get divided into 10 and the internet speed will get lower and the experience will not be that good. And imagine 100 users connect to the base station. What will happen? Each user will get 1 mega. Imagine you are watching a YouTube video or anything like HD definition. How would the experience be? Extremely bad and terrible. So we said that this is due to the fact that Wi-Fi is using PD-NOMA, a combination of PD-NOMA and OFDMA. And both of these techniques are limited in resources. Basically, the main principle of how these techniques operate is they divide the resources time and frequency. When I say the resources in wireless networks, it means time and frequency. They divide them equally into the users or based on the application you are using. Up until here, FDM, TDM, they were using the same thing, and we talked about NOMA, which is a technique that was proposed for 5G and then got rejected because of these problems, so many problems. And then we said we are gonna come up, we as group, as class, with a better technique that can fix all these problems. And the technique we came up with, we thought of, is called HAMUX. And this HAMUX technique works like this. You get the user 1 data, user 2 data, you have a network where you have base station, you have 2 users, and you have user 1 and 1, user 2. The main idea of the technique is with each user data, with each block of data for each user, we add on top of it auxiliary signal called R1 or R2. For user 2, R2, for user 1, R1. And then the signal becomes, in the frequency domain, x1 equal u1 plus r1, and here becomes x2, u2 plus r2. And then it passes through the OFDM normal operation, where you have IFT, inverse fast Fourier transform. It takes the signal from time, from frequency to time, and then you add CP to protect your signal from the multidata, and then you add windowing filtering to get rid of the side loops or suppress them a little bit and get rid of the adjacent interference out of band emission. And then you pass it through digital to analog converter. And once we reach to the digital to analog converter, we said that after that we have this device. This is done in the PC or any compute device like Raspberry Pi or PC or any computer device. And after that, you do this on the radio. This is the radio that they take the signal, oscillator, digital to analog converter, analog to digital converter, and then transmit your signal from the antenna. And we said if we ask you to do modeling for this, mathematical modeling, what happens here, you have to write user 1, user 2 data. What will be the signal that's captured by user 1? Here, U1, H1, the channel between them, U1 plus R2, and because the antenna at the transmitter propagating in all the direction, it means that it can also capture the signal related to user 2, which is U2 plus R2, multiplied by the channel plus noise. And the same for user 2. User 2 will get what? H2 multiplied by user 2 plus R2 plus H1, U1 plus R1 plus N2. Okay? And then we said the question here is how to design R1 and R2 so that each user will get his own data. This user will get just only this term, this user will get only just this term without any interference. If we want to simplify them a little bit more, we can do the following. Throw your phone out, throw. Stop using it, don't use it. U1, if we want to simplify it a little bit, U1 and U2. So we want to simplify it in a way where we put the desired signal into one term and the undesired signal into another term. And the goal will be to get this desired signal and get rid of the undesired signal. So Y1 here, what will it be? If I want Y1, I will put H1, U2, H1, Y1. This is the term I want. This is my signal for the user 1. This is my signal. Everything else is interference to me, and I want to get rid of it. Plus H1, R1, plus H2, U2, plus H2, R2, plus N1. So this term, this whole term is interference. And I want this to be 0, my design goal. For user 2, can you tell me what Y2 will be? H2, this is the desired term. This is my signal. I want this. I'm interested in getting this. This is my own signal. But everything else, H2, R2 plus H1, U1 plus H1, R1 plus N2. Everything else here is interference with respect to user 2, and I want it to be 0 as well. So this is, I want this to be 0, I want this to be 0. Linear algebra course, solve these equations and find R1 and R2 that can satisfy these conditions. This is homework for you till next lecture. Find R1 and R2 that can satisfy these conditions. I want this term as is, I want this term as is, but I want this term to be 0, I want this term to be 0. What's the value of R1 and R2? So next lecture, or until next lecture, you are supposed to find the values of R1 and R2 that can make sure you get 0 interference. You can take a screenshot of this, remember it, and solve these equations at home. And if you get more time, I want you to simulate this in MATLAB and see what results you will get. Okay? Okay, you can take a picture of this. You took it? Okay, very good. So what's the time now, exactly? So 50. We almost have 1 hour. So for the ones who are new, we discussed the project that we will do together. The project is about base station. We will build the base station together. And I will assign a specific task to each one in the group, to each one in the class. And each one of you will participate by his effort, time, knowledge, and money. Because the project costs some money. The money is not much, very little, because we will divide it into all of us. And the goal, we will build it and make it work. We will build a base station like this, modern base station. Okay? Tower. Like you have your phone with you. Where do you get your signal from? From the closest tower to you, yes? We will build that tower, we will build the intelligence inside that tower that gives you the signal over here. Okay? I will send you an IBAN number. Everybody with me? An IBAN number to send your contribution to the project so that we can buy the equipment and devices and start working on them. And I will send some of you to the factory that we will design the circuits at. Okay? We have to design some circuits and some boards. We have to go to the factory. Some of you will. I will send you interns, like each 5 people together, so that you can see the process of how things can be manufactured and can be designed. So we have 2 parts basically. First we will build the base station, and then we will build the power amplifier and base station. And the power amplifier is to amplify the signal and make it reach to 1 kilo, 2 kilometers. And what else? We have software and hardware. The software is an open source thing. We will tell you how to integrate it. And we have to build the SIM cards. SIM cards, there are 2 ways of building them. Either physically, hardware thing, you have like the SIM card you have inside phone, or electronically, like